Have you ever been tickled? Really tickled, I mean. Someone else's fingers dance across your ribs or the soles of your feet. An uncontrollable laughter erupts, your body squirms trying to escape the sensation. It's a strange mix, isn't it? Part pleasure, part mild torture. This feeling is almost universal among humans. We giggle, we shriek, we beg for it to stop, sometimes while secretly wanting more. It's a peculiar human experience, one that often starts in childhood and can continue to bring about bursts of laughter even in adulthood. Now try something, try to tickle yourself. Go ahead, I'll wait. Wiggle your fingers on your own armpit. Rub them under your own chin. What happens? Probably not much, right? The intense, squirm-inducing, laugh-out-loud sensation just isn't there. You might feel the touch, the movement of your skin, but that overwhelming, uncontrollable urge to laugh, it's missing. This isn't just you, it's a common human trait. We simply can't replicate that ticklish feeling on ourselves. The key ingredient in a successful tickle is surprise. Think about it, when someone else tickles you, you don't always know exactly when or where their fingers will land. That unpredictability is crucial. Your brain registers the touch as an external event, something it didn't initiate and therefore can't perfectly anticipate. This element of the unknown triggers a different kind of neural response. It's like an alarm system, albeit a usually playful one, alerting you to an external stimulus making contact with your body. Our brains are prediction machines. They are constantly trying to anticipate what will happen next based on past experiences and current actions. When you decide to move your arm, for example, your brain sends out motor commands to your muscles, but it also sends a copy of these commands, called an efference copy, to other parts of the brain. This copy essentially tells the sensory systems, hey, we're about to do this, so expect these sensations. This internal heads-up is incredibly important for distinguishing self-generated stimuli from external ones. When you try to tickle yourself, there's no surprise. Your brain knows your intentions. It knows where your fingers are going and what the sensation will feel like, more or less. Because the movement is self-initiated, the efference copy has already informed the sensory parts of your brain. The predicted sensation matches the actual sensation. Now, let's zoom in on a specific part of the brain that plays a starring role in this ticklish tale, the cerebellum. Located at the back of your skull, beneath the main cerebrum, the cerebellum might look small, but it's a powerhouse. It contains more neurons than the rest of the brain combined. For a long time, scientists thought its main job was just coordinating balance and movement, like a sophisticated autopilot for your body, and it does that exceptionally well. But its role is far more nuanced and fascinating, extending into the realm of sensory prediction. The cerebellum is crucial for predicting the sensory consequences of our own actions. When your brain's motor cortex plans a movement, like reaching out to tickle your own side, it sends signals to your muscles. Simultaneously, as we mentioned, an efference copy of these motor commands is dispatched to the cerebellum. The cerebellum then uses this information to generate a precise prediction of the sensations you feel as a result of that movement. It's like an internal simulator, running a quick forecast of what's about to happen to your body because of your own actions. Section 4. Breaking the rules when self-tickling is possible. So, the general rule is, you can't tickle yourself. But in science, rules often have fascinating exceptions. And these exceptions can teach us even more about how things normally work. Are there any circumstances under which a person tickled themselves? The answer, intriguingly, is yes sometimes. These situations usually involve a disruption in the brain's ability to accurately predict and cancel out self-generated sensations. This points directly back to the importance of that predictive mechanism we've been discussing, especially the role of the cerebellum. One area where this has been observed is in individuals with certain neurological or psychiatric conditions, such as schizophrenia. Some studies have suggested that people experiencing symptoms like auditory hallucinations or delusions of control may have a less effective sensory attenuation mechanism. Their brains might not be as good at recognizing sensations as self-produced. Consequently, when they try to tickle themselves, their brain might process the sensation more like an external touch, leading to a ticklish feeling. This suggests a breakdown in the precise timing or comparison between the motor command and the sensory feedback. Section 5. An ancient reflex. The evolutionary roots of ticklishness. Why are we ticklish at all? It seems like such a frivolous, almost silly reflex. But evolution rarely keeps things around if they don't serve some kind of purpose, even if that purpose isn't immediately obvious in our modern lives. Scientists have proposed several theories about the evolutionary advantages of being ticklish. These ideas often revolve around protection, social bonding, and learning. The fact that certain areas of the body are more ticklish than others, like the feet, armpits, neck, and ribs, offers some clues. These are often vulnerable areas. One prominent theory suggests that ticklishness, particularly the light, itchy kind called nismesis, evolved as a defense mechanism. Imagine our ancient ancestors living in environments teeming with insects, spiders, or other small creatures that could bite, sting, or transmit disease. Section 6. The brain's gatekeeper, filtering our sensory world. Our brains are constantly bombarded with an incredible amount of sensory information. Every second your eyes, ears, skin, nose, and tongue are gathering data from the world around you and from within your own body. If your brain tried to consciously process every single bit of this information with equal attention, it would be completely overwhelmed. You wouldn't be able to focus on anything. Imagine trying to read a book while being acutely aware of the feeling of your clothes, the hum of the refrigerator, the scent of the air, and the pressure of your feet on the floor, all at maximum volume. To manage this sensory flood, the brain acts as a sophisticated gatekeeper, a highly efficient filter. It has to decide what's important and what can be safely ignored or processed at a lower level of awareness. Section 7. The Tickle Conundrum, a window into self-awareness. The seemingly simple question of why you can't tickle yourself opens a fascinating window into some of the most complex operations of the human brain, including the very nature of self-awareness. It's not just a quirky biological fact, it's a direct consequence of how our brains distinguish between self and other. This ability is fundamental to our experience of being an individual, an agent acting within the world, rather than just passively experiencing sensations. The tickle phenomenon is a daily, personal demonstration of this profound neural process at work. The cerebellum, as we've seen, plays that critical role as the predictor and canceller of self-generated sensations. By creating an internal forecast of what our own movements will feel like, and then dampening the actual sensory feedback if it matches, the brain effectively tags those sensations as mine. This tagging is a cornerstone of bodily self-awareness. It's what allows you to know that the hand you see moving is your hand, and the touch you feel is your touch. Without this, the boundary between oneself and the external world could become blurred.